Good morning, Algebra 2. Here is the second page of our 2.1, I'm calling them notes. Whatever you call them, they're the factoring review notes. So, the difference of squares is something that uses the formula, or is in the form, of a squared minus b squared. And when we have something in this form, it's really nice because we can put it into the form a minus b times a plus b. This is just something good to know, so I'm going to put it up here and I'm going to box it, because that's what I'm going to be coming back to. I know if anything is in this form, I'll be able to break it down into its factors. So with this first one here, I see that the first term is something that has been squared, and the second term is something that's been squared. When I find the difference of squares, when I'm learning it, I like to identify what my a and my b are. And a and b are the unsquared, or the square root version, of my two terms. So the square root version of my first term is just going to be x. And the square root version of my second term is just going to be 8. Now notice, I didn't touch this negative, and the reason I didn't touch it is because it's part of the formula. If it's part of the formula, it's nothing I have to deal with. It just tells me that I can use this formula to set up my factors. Once I have my a and b, all I'm going to do is plug them into the positions where they go in my equation here. So wherever I saw an a, I plugged it in. Wherever I saw a b, I plugged it in, and then I just kept my signs the same. Again, because they are part of the formula. Alright, let's jump on to this next one. So your gut reaction is telling you a is x and b is 1. But you got to pause and think about this. Notice the difference between your equation formula and your problem. What is different? This little plus sign. That little plus sign, if we rewrite this, shows us that our actual equation that we're working with, let's put that as 0x, is x squared plus 0x plus 1. What factors add to 0 and multiply to positive 1? There are none. So this is not something that can be factored, which means it is prime. Remember, prime means that it has no factors other than itself and 1. So the only thing that I could say is a factor is 1 and x squared plus 1. But since this is redundant, we don't write it. We just write prime. Alright, this next one looks really gross, but I promise it's not. Still just break down your terms a and b first. What is squared in your first term? Well, when we take the square root, it's essentially like dividing the exponent by 2. And when we do that, we get x cubed y squared. And then in the second one, what is squared? Numerically, it's 8, and it's z. And just because these terms have multiple terms doesn't mean we don't just plug them in the same way. We're still going to say x cubed y squared minus 8z, x cubed y squared plus 8z. And that is your final answer. Alright, let's jump down to this next one here. Notice something quickly. This is x to the 4th. This is not x squared. So when we put our factor down, or I'm sorry, our a down, this term, when it's unsquared, is actually going to be x squared. And then our b is going to be 4. Alright, when we write this out, I'm going to write it a little differently. This time I'm going to write x squared plus 4, x squared minus 4. Pause. What do you notice about this answer? This is fine, but this is in that form that we like again. This is in that a squared minus b squared, because our x is squared and our 4 is squared. So we're going to do the exact same process again and break it down like we did above. So we can break this down even further and say this second term is actually factorable into x plus 2 and x minus 2. But this is still part of the original factor, so we have to bring this down and add it to our answer. Because if we want to get back up to our original problem, we have to include all of our factors, which are right there. Alright, last one for difference of squares. Notice, this is not in a difference of squares form we're used to or that we like. So what we have to do here before we actually start factoring with a difference of squares is we have to pull out the GCF, the greatest common factor. Between these two, it is 5a, but you'll notice once I pull that 5a out, I'm left with a squared minus 25. Now we do have a difference of squares that we can work with. Our a is nicely just a this time. Our b is 5, so we write a plus 5, a minus 5. Don't forget to bring that other piece down, 5a. The analogy I give is if you cut a steak into 3 pieces, you wouldn't just leave one piece on the plate, you would also want to eat that. So make sure you bring that down. Alright, perfect square trinomials. For perfect square trinomials, we have 2 equations. We either have something in the form a squared plus 2ab plus b squared, or we have something in the form a squared minus 2ab plus b squared. And between the two of these, the only thing that has changed is this sign in front. And when we put these into their factored forms, which actually look a lot nicer than their unfactored forms, the only thing that will change about them is that middle piece. So if you start with a positive in the middle, you have to end with a positive in the middle. If you start with a negative in the middle, you have to end with a negative in the middle. So notice this one. If we look at this first term, we notice the 25 is squared, the x is squared. If we look at the constant term, that's also squared. We can always say it's squared even if it's not, because 1 is a really cool number like that. And then notice the middle term. If my a in this case is 5x, in my b, meaning my constant unsquared is 1, my middle term is 2a times b. Well, 2 times 5x times 1 is just 10x. So this is in the perfect square trinomial form. Once we have our a and our b, all we have to say is, well, was this first addition sign was right there, so we're going to use this formula, and we're just going to say, well, it's 5x plus 1 squared. That's all it is. So when you see something big and gross like this, before you go right to doing a diamond puzzle, you want to first check and see, well, if I find the a of this first term, and I find the b, the unfactored form, is that thing in the middle 2 times a times b? If it is, it's really nice because you can just quickly factor it and say, well, notice it has a negative, so I'm using the negative version. I can just quickly put it into this form. Alright, last one here. Again, if I check my a, I see it's 3m squared. Quick note, that's an m to the 4th. So I want to make sure when I unfactor it that it's m squared. B, when I unfactor that thing behind, it's going to be 8n. Check your piece in the middle is 2 times m squared times 8n. Yep, we're good to go, so we can finalize it and put it in the form 3m squared. This is subtraction, so we put a subtraction symbol, squared. That's all there is to it for perfect square trinomials. So before you get to doing that diamond puzzle on these, make sure it's not in that perfect square trinomial form that we like. Alright, let's hop to the back side. This one's really nice. I've already given you the formulas at the top, so if anything is ever in this form, a cubed plus b cubed, we automatically know we can bounce into this factored form. Same thing with the negative version. Notice all that changes between Form 1 and Form 2 is if you have a positive here, there's a positive there, and then there's only one negative in the whole problem. It's kind of sandwiched in here. If you start out with a negative, you have to start out with a negative, and then these two flip, so this becomes a positive. So my memory device with this is, if you can remember one, all you have to do is remember that these signs flip. your positive goes inside, your negative goes outside. Alright, this first one, we notice it's in the a cubed minus b cubed form. So we start by finding our a, which is x, the uncubed version. We find our uncubed version of b, which is y. And then when we plug it in, we plug it into this form and say, well, x minus y times whatever this is squared. So we actually have to say x squared plus x times y plus y squared. The hardest thing I think about these problems is that you have to remember to square your a and your b when you put it back into this form. And I don't just want you to write whatever term a and b are in parentheses and then say, oh, this whole term is squared. No, we should be working on simplifying it. So this next one, your a is going to be 2m. Notice because I took the cubed root of my 8. I've got b. What is the uncubed version of 27? It's 3. Let's zoom out here just a little bit. Notice I have a positive, so I'm going to 2m plus 3. Outside of 2m squared is going to be 4m squared. Notice I squared both terms, not just one or the other. Minus a times b, well, 2m times 3 is 6m. Plus b squared, 3 squared is just 9. Final factored form is right there. Alright, last one in the sum or difference. A is 3x squared. B is 5. Alright, our final piece of factoring is our grouping. And we did this a little bit when we were doing the X puzzles or diamond puzzles, but it's always just a nice refresher. So when we're doing 4 terms of grouping, the key here is 4 terms. If you see 4 separate terms, you should probably try to factor by grouping. Also, if it's called factor by grouping, we should probably start by grouping our numbers. So I'm just going to pull the first 2 and the second 2. I'm going to say, what do the first 2 have in common? Well, they have an x. So I'm going to factor that out. Well, what's left? X and a minus y. I bring the positive sign down here, the plus sign. What do the second 2 have in common? Well, they have a z. When I factor that out, I'm left with x minus y. Oh, well, when it's in this form, I see that they have a greatest common factor of x minus y. When I factor that out of my first term, I have just an x left over. When I factor it out of my second term, I have a positive z left over. So, after I've factored that out, that is my factored form. You could do the same thing here. I personally like to, for some reason, if I see they have a coefficient, I like to group those terms. Maybe this is just one of my quirks, but I think it makes it look a little bit nicer. So if these both have a 2a in common, I'm going to pull that outside and say that an a is left and a c is left. Positive, because there's a positive in front of this. What do a, b, and b, c have in common? They have a b. I'm left with an a plus c. Now, if you had grouped it the other way with the first 2 and the second 2, would it have still worked? Absolutely. But I personally like to get it this way because then I can say, well, the 2a and the b are left when I have factored out an a plus a c. On this last problem, this one's probably easiest to see because coefficients in the back have something in common. But these ones, if you have more than 2 x's, I always like to try and group those and then just pull out as many x's as you possibly can to make that look more simple. So these ones have x squared in common. When I pull those out, I'm left with x minus 3. When I group the second 2, and I just bring the negative down, I see I can pull a 4 out of both of these. So I'm left with x, well, since I pulled a negative 4 out, actually, I would have had to group it this way. And when I pulled a negative out of that term, it would be minus 3. Because if I had put that as a plus 3, I would have ended up with a negative 12. That wouldn't have worked. So what terms are left over when I factor out an x minus 3? My x squared is left over, and my 4 is left over. Quick pause on this though. When you get here, you should notice this is a squared term minus a squared term. What can we do with that? Yes, we can factor it down into a difference of squares. In this case, it's going to be x minus 2, x plus 2. Again, you don't leave steak on the plate. You bring down that other factor and box it. I guess I'll box this answer too so you know which one was right. And that is all there is for grouping. If you have any questions, let me know.